All right, so what are we working on today, right? This is a unique problem. I'm gonna tell you right now, you need two equations. The first equation is what we used yesterday, or not yesterday, Monday, right? And that is, of course, Ohm's law. Start by writing everything in that box. Once you're done, I'm gonna give you one more to write down because it adds to this equation. So what am I talking about? You're writing everything in that box. I'm seeing people put just the equation. Above the equation with the letters is what they mean. You have to write those down. If you don't, I'm subtracting. He gave 2 sheets. 3. I gotta order some more. So page that you want to go to in the book to get your first part of your notes, 751. Okay. Again, a lot of y'all are skimping out on that. If you shrug your shoulders and not do it, it's -10 for each section you don't have in your notes. So if you want to keep your points, I suggest you do everything you're supposed to. Yes, yes. Jomi, I think you've seen this problem before.
You gonna do that library thing again this morning?
Not until the end. Not to the end. I know y'all trying to script and say little points here and there, but that's like a save to the end. So I know, and I was just saying, nope, not to the end. That's about 30 a month and 6 days away before you can start talking about that. All right. Anyway, what was I saying? Let's docket this problem out. Everybody, go down to your we do section. Okay. That's the problem. Is it recording yet? So what do? We start by identifying the equations we need to solve this newer problem. We talked about what a series circuit is. We'll see what that is in more depth in our simulation tomorrow because we have more time. But let's knock this out. So the first equation I told you to jot down was what? Ohm's law, right? Let's write it out. This is known as Ohm's law. If you wrote what's in that box on that page 751, you don't have to worry about what I'm writing in this first part of your notes because you got it in that box. So type it while I'm talking about this. So Ohm's law is composed of V is equal to I times R. Now your description is going to say what they are above that equation. Type it in because it has to make sense. No, you don't have an account. You're writing it down. When y'all get an SB, then y'all type it. So what do each of these mean? Well, let's talk about how they're measured. When we talk about resistance, that's something known as ohms. Or you're going to see a lot something called omega, this little symbol here. Okay. Next, we have I, that's our amps. This is our current. This V stands for voltage. Or volts is how it's measured. And that's pretty much the first part of your notes here. Okay, this is number 1. Number 2 of your notes. Again, this is page 751. So again, it's not to explain. You gotta crack that book open. Do it now because you're gonna ask me again. You crack the book open first, and I can tell you what you're typing. Because you don't have to type what I'm typing if you open the book up and type what's on. Like I said, for the time. 751, you got to write everything in that box. That's why you worried about this. This is just me explaining that box. Okay? So, look, y'all are not really trying to rewrite what I have here. I'm explaining that equation. Y'all are typing everything in that box to get the credit for it. And that includes applied voltage is equal to current times resistance. That's something y'all not typing. You got to type all that or write all that. All right, number 2 of your notes. I'll tell you what page this is. Remember, this also comes from the book. This is known as the equation for, this is number 2 here of your notes. This is called equivalent resistance. Let's flip to the right page. So this equation is found on page 758. So let me know when you get done with the first part of your notes. Go to 758, I'll tell you what the next part. The equation is known as equivalent resistance And that's for resistors. Huh? What are you talking about? You just write what's in the box. Yeah, she get confused. 751. You write what's in this box here. That's all you write. That's what I said. Don't make it hard on yourselves. Everything in that box. You can. I'm looking for that. But this is me explaining what they mean. That's telling you what it is. All right. Equivalent resistance for series resistors in series. Right? And what does that equation look like? Well, it's just pretty much a linear equation. It adds everything up based upon how many resistors you got. So equivalent resistance means REQ. You want to know how to write that. For this part, go to 758 if you're done with 751. There's a little green box that covers this one. All right? So what am I talking about? Talking about this box here. You're supposed to write that after you wrote the other box. But wait till you're done with 751, go to 758 to get this next part. Okay? If you need help, let me know. So it's REQ, R sub EQ. Some of y'all are putting REQ capitalized. That's wrong. It has to be written the same way it is on the page of 758. Is equal to R sub 1 for resistor 1, plus R sub 2 for resistor 2, plus R sub 3 for resistor 3. And plus dot 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 in that box on page 758 means that you have R4, 5, 6, so on and so forth. So all of these are measured in terms of ohms, right? Or omegas. Right? If you need help finding that character when you're typing it, let me know. I can show you how to insert it. Okay? Now, part 3 of our notes. Known and unknown values. What are our ingredients, right? So let's take a look here. Number 3. And I'm numbering in case, you know, you start off from top to bottom. So you get 1 done, right underneath 1, 2, 3, so on and so forth. Yes? Yes, you can. How about that? So known values. And unknown. What do we ask? What's being asked of us? Okay? So let's write this out. Do as quick as I can because we're going to run out of time. Get it at 150. So we start off with a new Greek letter, and this is in terms of our battery, right? Some of my veteran students who've had me before remember that this is known as electromotive force. The character is called epsilon. Epsilon is a battery source. So we would say epsilon is equal to, and we look for what is known as volts at the end of the number to know where to put it. So this is not E right here. This is called epsilon, all right? It's a Greek letter for my people that are typing. It's equal to, in the problem set, 28.3 volts. Please put your dimensions after your numbers. Some people are losing points for the smallest things. Those things matter. Continuing on. That's our electromagnetic force of our battery. And then we got some resistor values and a current to add to this too, right? So the only thing we're missing is, in this equation, R3. So let's go ahead and knock that out, right? So R3, what are we working on? That's our current. It says amps, right? We know anything that says amps is a current from our explanation earlier. That's equal to, I gotta explain one more equation for y'all too, though. Yeah, it's in here, but I'll talk about it a little later. I'll do this last, y'all. Huh? The one in the corner of R. What do you mean, like subscript? So you highlight the 1 after you type it, right? And then if you go to format, I think it is, I think it's text, because it's like a menu drop down. Text, and then you'll see something called subscript. Subscript. So y'all, this is gonna be number 4, because there's one equation you need more. And it's over here. This is the EMF version for Ohm's law. Make sure y'all get that. And that is, when you type this one, this is one other section you know. This is actually part 3, y'all. Okay, there we go. So this is going to be looking like epsilon is equal to I total. This is an equation you got to write from the board. And REQ, you're going to need that as well, okay? Again, this character is known as your volts, but its name, the character itself, if I could write that for you, as epsilon. That's a Greek letter. Let me know if you need help finding it. And this is known as current as well of the system. And this again is always measured in ohms, right? All right, so make sure you have all those. Now part 4, there we go. So now, so we got for current 0.0549 amps. Moving on, R1. That was 250 omega. R2, right? That was 188.78 omega. R3 was, R3 we don't know yet. We're trying to find that, right? So to find this, we need to first find REQ, which we can do, right? Using this equation. So we got to first find REQ. It's R sub EQ, y'all. Like Ms. Tolliver said, it drops down. Omega. Write that better. And then you got also your R3 value, which you're going to find it from pretty much using this equation here. Yes? That's what? That's not E.
No, up there.
EMF. No problem. But that is not an E or a 3, y'all. That's a Greek letter called epsilon. Just making sure you know that.
You said called what?
Epsilon. It's spelled like this. Okay? All right. Now, we got everything we need. We'll box this off, and we're going to go to part 5 where we start solving it. We got part 6 where we'll finish it. So let's come down here. And all these are still part of part A of the question. So this will be, what, number 5 in how you set up your notes. But these are all considered part A solution values. We haven't even got to part B. We'll look at part B after we do part A again tomorrow, so you have more time to think about it. But get everything for part A. So part A, what do we do? Well, first we want to solve, like I said earlier, for REQ. Right? This allows us to get to R3. To do so, we have to do a little bit of algebra. This problem uses I would say I would say middle level of algebra, because you got to do algebra in 2 sections. So what do? Write this equation in the third procedure over here. Epsilon, you got to write it as it is. It's not a 3 or an E, it's a Greek letter. Look for something that looks like that. I total current, and equivalent resistance is the equation. Come down one. We're going to say, just going to rewrite it, and we're going to separate it using our algebra skills. Right? So if I look at this, I see it's a multiplication procedure. I got to do the opposite of multiplication, and that's division. Question. What are you talking about? This? No, it's epsilon. That's what somebody else asked me. Epsilon. You got to find the Greek letter epsilon. If you need help, we got helpers around the room like Joe Mill and Nicole. All right, they can show you how to put it into your typing. So we're going to divide by I total in this case. And I total is going to be the current. It's the only current we got. So we're going to use that. What you do to one side, you got to do to the other. We can cross out our I totals and rewrite and then get our REQ based upon our new solution. So come down one. Next step would be, hey, like I said, rewrite the equation. Epsilon over I total. And come down one more. REQ is equal to, plug in your numbers from the ingredients you got. So we know that epsilon was this, right? That's 28.3 volts. And that's divided by our I total of 0.0549 17.49 amps. Okay. Now we're gonna come down and just calculate it. And then we can find our final step in the procedure for part A is solving for R3 using some more algebra. But let's go ahead and calculate that. Where's my calculator? Oh. So if I'm using this correctly, it is just use your fraction button. You can also do it in Google. If you need me to show you how to type it in, just let me know, or let one of the lab assistants know. So what is the top number? 28.3. Come down to 0.0549. I get a yield of 515.48. Okay. It's 8. 48. Yep.
Is that TOT and
Yeah, TOT for total, but it's subscripted like the other one. Okay. You got it or no? Okay. Somebody help her out. Who knows how to type that in? So you type TOT dot, highlight the TOT dot, use your subscript to drop it down. It's just like a math notation. Okay. This is your answer to RQ.
how do I use the subscript?
Again, you got to go to format up top, right? And then you go to text, and it's just, there's an option that says subscript. Okay, you first got to highlight what you want to subscript. All right, so this is the end of that part of your notes, but we still are not done because we need R3. We got RQ now. This is what we were searching for. We now need to get R3, and then we'll be done with this. So I'm gonna put down here, state your case. Again, some people are not putting what you're doing in each step. I do it, so you gotta do it. So this is still part A. I'm gonna say part A, continued. And you're solving now for, what do we say, R3 now, right? So for this part, you gotta use that equation in number 2 of your notes and do some algebra to get R3 by itself because we have RQ and all the other resistors. So let's do that. Come down one, rewrite the equation for equivalent resistance for series circuits. So let's do that. Right? And then come down one more, we'll scoot over because we got lots to write. And rewrite the equation. And we're gonna do some algebra on it. All right, now, if we look at this situation here, this is a step by itself. Look at a situation like this, and there's a reason why I scooted it over, because we gotta do some algebra on it. We wanna get R3 by itself. So the simplest way is to remove everything that's not R3 around us. In this case, that's R1 and an R2. So it's positive, we go negative because that's the algebraic way to do it. So we just come over and we say minus R1, right? Minus R2, and what you do to one side, you got to do to the other. Okay, that allows us to cross out some things and rewrite the equation. So yes.
What is that called under the algorithm?
Under the what?
God known. And it's under the volts. What is that called?
Epsilon.
No, I know. Okay, I know that. But what's the other one called under that?
Huh?
Yes.
I?
Yes.
It's just I.
Oh.
Yeah. Okay.
How do I take off the subscript?
How do you what?
Take it off.
The same way you turned it on. So same procedure. Okay, I don't know. You gotta bring your laptop over here, and I can try to help you.
What time is class in?
You can take a look up there. I gotta finish teaching. I can't answer 1,000 questions, but yeah, you want to show it, Jamarion, where that's at? I'm not being rude, but I can't keep stopping y'all. All right, so look, you gotta rewrite this now because we removed what we didn't want and plug in our numbers. So we got R3 is now equal to, just bring this all over. And then plug in your numbers to finish it off. So let's plug it in. The values are up there, plus this one we just figured out. We're gonna use this over here. So, and this is, what did I say, part 6 of your notes, y'all? so that becomes negative, parentheses, use your values. That's 250 ohms. Minus, what's our R2? This one? Right? Plus, we got this joker. And now all we gotta do is calculate, okay? I will take a picture of this in case y'all run out of time, all right? But you're responsible for all parts. Because it's called, I don't like kids in the street and doing nothing stupid, so you got homework. That's what it's called. When I was in school, I had homework. I know these CPS kids, y'all got homework. So what you don't finish in class, you got homework. That's not my fault, but I'm gonna treat y'all the way I was raised. Talking about how that's how. You gotta make sure you learn. It stops kids from getting this stupid stuff outside. Okay, that's what he's talking about there? All right, I'm about to calculate this last part, take a picture. You'll have it in SB. You got to finish it. What you don't finish in class, like I said, I'm sorry. I know my way to keep y'all out of danger is to give you homework. Okay? So go to a library if you have a computer, but it's better than hearing about, people getting murdered and whatnot. You do something like academic, you'll be all right. So let's go ahead and calculate this. You okay, Jamil? You got the same thing almost? You a little rusty? You quiet. It's okay. You have more practice over the time, man. You've done this stuff before. All right. Start finishing up. So the final answer to R3 is 76.7 ohms, or a mega. Okay, there is an exit slip that you have to use the book for. If you need to use the book, just ask staff you can borrow one. I'm about to get out your way. Because I'm not. Recording points go to who, Nicole? I forgot.